Let's draw the dehydration reaction of 1-propanol. Now when we talk about a dehydration reaction, that means we are removing water. So I would like to redraw this molecule in a structural formula so that we can see where the water that we are removing actually comes from. This alcohol group I'm going to put on the end here where it is. And then the rest of the bonds are, the rest of the 4 bonds to each carbon are made up by hydrogen. When we remove water from an alcohol, what we are removing is we're removing the OH part, and we're also removing an adjacent hydrogen from a carbon next to the alcohol. The hydrogen does not come from here, the hydrogen comes from another carbon. Therefore, when we remove the H and the OH, we're going to make water, and we're also going to make a double bond. So the result of dehydration of an alcohol is going to be an alkene. In order for this reaction to happen, we need to have an acid catalyst. In this case, I'm going to use some sulfuric acid. And what we're going to do is we're going to make an alkene. The only carbon that is adjacent to this end carbon is this carbon right here. So that means that our double bond will be between these 2 carbons. So the way that I'm going to draw this, I have the 3 carbons because it's propanol. 1, 2, 3. I have the 3 carbons, and now there will be a double bond right there. And so this will be called 1-propene. The other product is water. The structural formula of the product will look like this. So every carbon has 4 bonds around it. 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. So the dehydration of an alcohol makes an alkene. In this case, this alcohol is a primary alcohol. And in that case, we get an alkene with the alkene at the end of the molecule.